Hello guys, my name is Bino, and in this video we'll be working through question 2 from the November 20, 2020 and 5 mathematics question paper. So question 2.2, we have to prove that if y is equal to arc cos of x, then when we differentiate y with respect to x, we will get negative 1 over the square root of 1 minus x squared. So we have y is equal to arc cos of x, which we can write as arc cos of x. So the first step is for us to remove this arc cos, and to remove this arc cos we have to switch the y and the x. We have to switch their places, so x will take the place of y and y will take the place of x, and from there we have successfully removed that arc cos, and from here we can differentiate. So the derivative of this x is equal to 1, and the derivative of this cos is equal to negative sine y, but we have to indicate that we have differentiated this with respect to x, so we have dy over dx. Actually what we are supposed to have, so the derivative of this x is equal to 1, but you have to indicate that you have derived x by putting in that dx. The derivative of this cos y is negative sine y, but you have to have the dy so that you can indicate that you have differentiated this thing with respect to y. So from here we divide both sides by dx, so 1 will be equal to negative sine y dy over dx. So we can just write that dy over dx after we differentiate the part which has y. So from here, because we are looking for dy over dx, we divide both sides by sine y, by negative sine y. So that negative sine y will cancel out with that negative sine y, and on the left hand side we'll have 1 over negative sine y is equal to dy over dx. So now the dy over dx must not be in the form of y, it must be in the form of x. So in order for us to remove this y, so we have to refer to our trigonometric identities. So you'll follow the same procedure when you are proving the sine y. So we know that sine squared y plus cos squared y is equal to 1. So we make sine squared y the subject of the formula. So we'll have sine squared y is equal to 1 minus cos squared y, after taking this cos squared y to the right, and it changes sign from positive to negative. So sine squared y is equal to 1 minus cos squared y. But we have sine y here, we don't have sine squared y. So in order for us to have this sine y, we have to introduce the square root both sides. So sine squared y, and even this side we also introduce the square root. So we introduce the square root both sides, cos squared y. So the square will remove the square root, so that square will remove that square root, and we'll be left with sine y is equal to the square root of 1 minus cos squared y. So we apply the square root both sides, so sine y will be equal to the square root of 1 minus cos squared y. So in the place of this sine y, let's substitute the square root of 1 minus cos squared y. So this negative, we just keep it. So in the place of sine y, we substitute 1 minus cos squared y. This is equal to dy over dx. So we were told that, so after we change this thing from the arc, we said that x is equal to cos y. So in the place of that cos y, we substitute the x. We substitute x where there is cos y, because cos y is equal to x, and we want this thing in the form of x and not y. So this negative, we can take it to the numerator, or you can just keep it there. And in the place of this cos y, because cos y is equal to x, we substitute that x, and the cos is squared, so we also square this y. So dy over dx is equal to negative 1 over the square root of 1 minus x squared. So we have successfully proved that dy over dx is equal to that. Question 2.3, we have to determine dy over dx in each of the following cases. So 2.3.1, we have y is equals to the square root of sine of x plus ln of 5x. So we can write this as this square root, we can express it as this square root, we can express it as 1. We can express it as the exponent 1 over 2. So it's going to be easier for us to differentiate when the thing is like this than when it is like that. So we have to use the chain rule in order for us to differentiate this. So first we'll differentiate the parentheses, the brackets, and secondly we'll differentiate the sign. After differentiating the sign, we will differentiate what's inside the sign. So we'll so the derivative of the parentheses, so dy over dx. So the derivative of the parentheses, so we'll have 1 over 2 into sine of 7x plus ln of 5x. So 1 over 2 minus 1 will be equals to negative 1 over 2. So secondly, we differentiate the sign. When you differentiate the sign, you get cos of 7x plus ln of 5x. And now that you have successfully differentiated the cos, we have to differentiate what's inside the sign. So we differentiated that sign, we got the cos. Now we differentiate what's inside the sign. So the derivative of that 7x is equals to 7, and the derivative of ln of 5x is equals to 1 over 5x. And so we are supposed to also say for number 4, we differentiate. So we differentiated that ln and we got 1 over 5x, but we also have to differentiate what's inside the ln, the 5x. So the derivative of that 5x is equals to 5. So I'm sure they said simplification is not required. Question 2.3.2, we have to differentiate y is equals to 4 ln of sec squared x. So we have to differentiate first the ln, and we differentiate again the ln, and we differentiate again the square, and then we'll differentiate the sec. So the derivative of this ln, so we have dy over dx. So therefore we just leave it as it is. So the derivative of this first ln will divide by whatever it is that is inside this first ln. So inside this first ln, we have ln of sec squared x, and now we have to differentiate with what's inside. So now we have to differentiate this ln. So the derivative of this ln will be equals to whatever it is, 1 over whatever it is that is inside the ln. So in this case, it's the sec squared x, and from here now we have to differentiate the parentheses. So we have that sec squared x. We can express it as sec x squared. So now we differentiate. So that sec squared x, we write it as this. So it's easier for us to differentiate it when it's like this. So we differentiate first the parentheses, and later we'll differentiate the sec x. So this will be 2 sec x. The 2 minus 1 will be 1. So now we differentiate sec x. The derivative of sec x is sec x tan x, also available on the formula sheet. Question 2.4, we have to calculate dy over dx if y is equals to 3x squared plus 2, all of which will be raised to the power 1 over x with the aid of logarithmic differentiation. So we have to remove that exponent 1 over x and put it as a base, and in order for us to do that, we have to introduce our logarithmic laws. So if we had log of, so log of a raised to the power b, this will be b log a, but let's not work with log, let's work with ln. So if we had ln of a raised to the power b, this will be equals to b ln a. So let's introduce ln both sides of the equation so that that exponent like the way that it was removed there, will be part of the base. So we have ln of y. What you do on the left, you also do on the right. So this will be equals to, because of our logarithmic laws, the 1 over x will be removed from the exponent to the base. So this will be x, 1 over x, ln of 3x squared plus 2. And unfortunately, we cannot take that 2 from there because there is a positive in front of. So there is the plus 2. So it's not, that square is not squaring the whole thing. It's only squaring that x squared. And we also have the 3 and the 2. So from here, we have to differentiate. So when we differentiate this ln, so it's going to be 1 over whatever it is that is inside the ln, which is y, and the derivative of this y will be equals to 1. So there is no need for us to write it. And we also have to indicate the dy over dx after we differentiate anything which has y. So the derivative of this 1 over x multiplied by ln of 3x squared plus 2. So this is a product of two functions, 1 over x and ln of 3x squared plus 2. So we have to use the product rule. So the product rule, so let's write this 1 over x as x to the power negative 1 so that we can differentiate this easily. Multiplied by ln of 3x squared plus 2. So our focus is that side. So the derivative of x to the power negative 1 will be negative x minus 1 will be equals to negative 2. And we multiply this thing by ln of 3x squared plus 2. And now we have to differentiate. So we differentiated that part and we multiplied with that part. Now we differentiate this part and we multiplied with that part. So the derivative of this ln will be equals to 1 over whatever it is that is inside the ln. Now we differentiate what's inside the ln. So the derivative of the 3x squared will be equals to 6x, and the derivative of that 2 will be equals to 0. And we multiply it by this as per the rules of the product rule. So x raised to the power negative 1. So from here, we are looking for dy over dx and not y, 1 over y dy over dx. So this dy over dx, it has to be the only thing which is on the left hand side. So 1 over 1 dy over dx. So let's try to simplify this. So this will be equals to negative ln of 3x squared plus 2. So that x to the power negative 2, we can take it to the denominator, and the exponent is going to change sign from negative 2 to positive 2 plus 6. So that x to the power 1 and that x to the power negative 1 will cancel out each other. So we'll have, so the bases are the same. We have the exponent, so we add the exponent. 1 minus 1 will be 0, and x, okay, let me do it. 1 minus 1, so the bases are the same. We add the exponents. So 1 minus 1 is equals to 0, and x raised to the power 0 is equals to 1. So any number or variable raised to the power 0 is equals to 1. So our denominator now we have 3x squared plus 2. So like I said, we are looking for dy over dx, not 1 over y multiplied by dy over dx. So we multiply both sides of the equation by y, so that that y can cancel out with that y. So dy over dx will be equals to y multiplied. So that y, let's bring it to the forefront. Since we are not differentiating implicitly, we cannot have y as part of our solution after we differentiate. But we know that y is equals to that. So in the place of this y, we substitute that because that is equals to y. So we substitute the 3x squared plus 2 raised to the power 1 over x in the place of this y, so that we can have all the x's this side. And this will be our answer for question 2.4. Question 2.5, we are given the implicit function x plus y divided by x minus y is equals to x. So we have to determine dy over dx. So before we can determine the dy over dx, we have x plus y over x minus y is equals to x. So in order for us to avoid differentiating this thing using the quotient rule, let's multiply both sides of the equation by x minus y, or you can differentiate using the quotient rule from here. So x plus y will be equals to x into x minus y. So from here we can further distribute this x inside the parentheses. So x multiplied by x will be equals to x squared, and x multiplied by y will be equals to negative xy. So from here we can differentiate. So the derivative of the x is equals to 1 and the derivative of the y is equals to 1, but we have to indicate the dy over dx after we differentiate any function which has y. The derivative of the x squared is equals to 2x. Remember that the derivative of this y was 1. And the derivative, so now we have two functions, x and y, we have to use the product rule. So the product rule, so we differentiate the x and we multiply it with the y, and we differentiate the y and we multiply it with the x. So the derivative of this x is equals to 1, and we multiply it with the 1. Remember your parenthesis, plus the derivative of this y is equals to 1, but we have to indicate that we differentiated something which has y, like we did here by including the dy over dx. And since we are using the product rule, we have to multiply this thing by x. So 1 plus dy over dx is equals to 2x. So we distribute this negative inside the parentheses. 1 multiplied by 1 will be equals to y, multiplied by this negative will be negative y. And this side, 1 multiplied by dy over dx will be equals to dy over dx. And we also have that x, okay? So this negative multiplied by that positive will be negative, the dy over dx, and it's multiplied by x. So from here we group anything which has dy over dx to one place and the one which doesn't have dy over dx to the other place. So let's take this. So we already have that dy over dx, and we invite this one to the left. It's going to change sign from negative to positive, dy over dx multiplied by x. So we have 2x and then minus y. So this one does not have dy over dx, so let's take it to the right. It's going to change sign from positive to negative 1. So you have dy over dx plus dy over dx. So we have dy over dx here and dy over dx there, so we can take the dy over dx as our common factor, and we'll be left with 1, and here we'll be left with the x, 2x minus y minus 1. So since we are looking for dy over dx, this equation by 1 plus x so that 1 plus x will cancel out with that 1 plus x, and we'll have dy over dx is equals to 2x minus y minus 1 over 1 plus x. So question 2.5.1, we have to determine the equation of the tangent to the graph at the point 0 and 1. So the dy over dx is equals to our gradient in the form of x. So now to determine the gradient, so to determine our gradient, where there is x we substitute the 0, and where there is y we substitute this one. So 2 multiplied by this 0 will be 0, so we'll be left with -1 minus 1, 1 plus 0, so there's no need for us to write it. So this will be equals to -2 divided by 1, which is, so after we substituted x for 0 and y for 1, we call that our gradient at this point is equals to -2. So we have y is equals to mx plus c, and our y, we use that point because we are only given 1 point, and where there is x we use, so our gradient we say that is -2, but we'll multiply it by the 0. So -2 multiplied by 0 will be equals to 0. So our c will be equals to 1. So our equation of the tangent will be equals to our gradient, which we determine as -2x, and our c, which we determine as 1. And that's it for question 2.5 and question 5. So if you have any questions, you can leave them in the comment section below. And if you find these videos useful, consider subscribing, liking, and sharing these videos with your fellow mates.